Today I'd like to talk about the transition from the fish to the tetrapod. So this is going to be number 4 in Dr. Martin's supplemental lectures on chapter, I believe we're on chapter 25. So this is chapter 25, section 4. So we've talked about the fish and some of the characteristics of cartilaginous fish and the bony fish. Now we're going to be looking at the amphibians and the reptiles and birds and so on. So we're actually going to talk about the transition from fish, which are adapted to an aquatic environment. And so all of the structural features that entails to an organism or group of organisms that we use the term tetrapod to refer to. Tetra means 4, pod means feet. So in this case we're talking about land animals that walk on all fours. So according to what scientists currently believe, the ancestor of the tetrapods, of the early tetrapods, probably appeared in the fossil record about 350 to 400 million years ago. We have there have been found a number of fossil finds that show transitional features between a fish and a tetrapod. And I'm going to mention one in particular. There's also one mentioned in your book. So let me talk about the one in your book briefly. Acanthostega is a transitional form that is shown in your textbook. This is figure 25-11, I believe. No, sorry, 13. And there is a picture of the skeleton as well as an artist's rendition. So this is an organism that had gills but actually had limbs that could help it propel itself in a shallow water environment. Another fossil that's rather famous now, it's a more recent find. This fossil is shown in this illustration, and this guy has been named Tiktaalik. It was found by a group of scientists in 2006. I believe it was the summer of 2006, and one of the discoverers, it's actually at University of Chicago, and his name is Neil Shubin, and he's written quite a lot about this particular fossil. So this fossil was found, I think in Greenland, very far north in the North American continent, and it has a number of features that are, we'll say, transitional, in that it has some features that are fish-like and it has some features that make it more like a land animal. And so Neil Shubin and his colleagues have dubbed this a fishapod. So here is the skeletal remains, and this is an artist's rendition of what the organism might have looked like. So if we look at some of the fish-like characteristics, certainly this particular organism had scales, it had fins, and it had gills, and actually lungs, which we did see in some of the fish. Now, it has a number of characteristics that link it to land animals, and so I'm going to list those here also. So these are tetrapod features. So number one, it actually has a neck. So there is a fish, obviously the head is rigidly joined to the rest of the body. In the case of Tiktaalik and as we go up the scale of the vertebrates, we tend to have a more mobile head that can move relative to the rest of the trunk. So we see that in Tiktaalik. In addition, they did see ribs, which indicates that lungs were present and that the organism was able to breathe air, as well as, because it had gills, it could extract oxygen from water. So we're looking at, again, a transitional organism that can live in an aquatic environment as well as a terrestrial environment. Perhaps it lived in shallow waters. The period of time when the amphibians which is the first group of tetrapods, were quite abundant in the fossil record, is a time that's called the Carboniferous period. And that's what the geologists call it. And this was about 300 to 350 million years ago. During this period, there were very lush forests and swamps present, and so it's likely that there were a lot of shallow water areas that this guy could live in. Another characteristic is that the fins are supported by bones like ours. There's very much a similarity between the pattern of bones in our limbs to the pattern of bones in the limb of these guys. And you can see how it looks like it's supporting its weight on that. So instead of spines like we see in the ray-finned fish that support the fins, we're now seeing actually larger bony structures. It has a flat head, and this is, remember, fish in general tend to have a head that is flattened in the opposite direction. Allows them to move through water more easily. These guys have a very non-fish-like head. They have a very flattened head. The eyes are, in contrast to a fish, the eyes have moved to the dorsal part of the head, more like a crocodile or alligator. And one last feature is the presence of ear notches in the skeleton, which indicates ear structures similar to what we see in the tetrapods. So this is a very interesting fossil. There's undoubtedly more will be found in the future. I want to point out, however, that this is not, this is an offshoot. All of these fossils that we've been finding appear to be offshoots from the main evolutionary line. So that's what I've illustrated here. So there's some relationship between Tiktaalik and the ancestor, whoops, I wrote that down wrong. It should be Tetrapods. The ancestor of the modern tetrapod. but it's not a direct link. This is not a direct link between fish and amphibians. All right. If you want to learn a little bit more about this particular organism, you can go to University of Chicago website, and they have a web page dedicated to this particular fossil.